Great.
Hello, so welcome from ChipEx in Israel. It's my pleasure to speak with Darren Hobbs. S3 is a very good part of the NR. So Darren Hobbs, who is the Director of Product Management, will tell us a little bit what they show at ChipEx. Please.
Gabrielle, thank you. Thank you for having me. So I'd like to talk today about choosing the best ADC for your SoC. So what I mean by SoC in that perspective is your typical consumer type SoCs. Everything from SoCs that manage, let's say, LTE type cellular links and also Wi-Fi. Because as we know in the consumer area, the consumer's got a voracious appetite for more content, quicker and faster. So what that does is that it places a lot of pressure on the receive chain. So that's what I'll focus on here today. And it's all about, when you talk receive chain, you're really talking about the bottleneck, and that tends to be the data converter itself, or the ADC. So I'm going to talk about today is literally that ADC itself and choosing the correct ADC for the application. So I mentioned before the consumer desire for more content and quicker. That places a lot of emphasis on bandwidth, right? Bandwidth and power. So what we do in S3 is when we specify ADCs, we talk about energy efficiency. And literally that's a measure of the performance you're getting per milliwatt burnt. And that's a very, very important metric because a lot of people tend to do a lot of specsmanship in ADDs. They say, well, it's 12-bit at a certain rate, but that doesn't really mean much. What's really important is how much ENOB you're getting in a certain bandwidth. So when you're speccing an ADC, it's important to look at two critical things. The ENOB, which is equivalent number of bits, over the bandwidth that you require to exist in. So let's talk then a little bit about the various type of ADC architectures that are available today. So the first architecture was typically a pipeline architecture, but now what we're doing is we're moving to a SAR architecture. And the benefits of a SAR architecture are that it's more appropriate to the particular nodes that we know operate in the consumer area, which would be 40 nanometers and below.
Okay, so I know that ADC is one of the hottest products on our website. The whole world is looking for the best ADC. So of course my question is, how do you compare with other such converters on the market?
Okay.
How do you compare with your competitor?
Okay, competitors. So what we've done is we've moved from a pipeline architecture to using a SAR type architecture. The beauty of a SAR architecture is that it tends to be more digital than analog, which means that it's more appropriate to use at deeper technology nodes, which is where consumer SoCs are going. And so what we've done is we've come up with a single core SAR architecture that pipes at 160 megasample per second. So that's the first single core 160 megasample on the market today. It's got the best energy efficiency of 31 femtojoules. So translating that back into real numbers, that means that it only burns 6 milliwatts, and it's a very, very small area. It's 0.09 square millimeters in 40 nanometers. It's exceptionally, exceptionally small. You can't beat that in size.
Okay, so it looks great. And what about the future? Have you a roadmap?
Yeah, certainly. So what we're going to do with the SARs, we're going to move that across the entire spectrum. So certainly from a standard perspective, this 160 megasample per second targets 802.11 AC, and it targets LTE very, very well, including the compression aspect of it. But what we're going to do next is we're going to interleave this and get 320 megasample per second, which goes after the next generation of AC. And then in time, we may play in the infrastructure place with this SAR ADC as well by slicing it a few times.
So it looks absolutely fabulous, and we thank you very much and good luck.
Yeah, thank you very much. Thank you, Gabrielle.